Hi everyone, we are going to do trigonometry this July session. So this is early start trig. I'm glad y'all decided to come and get trig out of the way over the summer. And so what I'm going to do is I'm going to make videos for multiple sections at a time, and then the sections that are in each video will correspond to the homework that would be available for classes. So before we get started, kind of a rundown of what's going to go on throughout the semester. First of all, if you haven't done it yet, check out your Canvas page. Your Canvas page will have all of your syllabi, so the syllabus for the course, how to figure out grades and stuff like that. It'll also have all of the videos that we're going to be doing here. So if you found this one, you probably found the rest of them as well. Uh, it also has a link to where your homework and your quizzes and your tests will be taken at. So all your homework, quizzes, and tests will be taking on MyLabs Plus. It is the website for your homework, quizzes, and tests. All your grades will be on that website. Along with that, also I'll have my office hours are posted on Canvas. They're going to be through WebEx. So there's information about that on the Canvas page. And if you have a question about email that I can answer through email, shoot me an email. My email, oh, I left the I out of email. I'm a bad speller, by the way. Is Banik, BANIK, at msstate.edu. So if you have any questions at all, come see me there. You will need a calculator that can do trig functions, especially when we get to some of the later sections that actually just tell you to find stuff on a calculator. So if you run into that, let me know if you have a question about a calculator or something, or just any questions at all in general. So let's get started. This course in trigonometry assumes that you've never seen anything in trig before, so we're going to hit the very basics in the first couple of sections. What are the definitions of trig functions? How do they apply to each other? How do they relate to each other? And so some of this you may even remember, even if you've never taken trig before, you might remember some of this from, say, a geometry class in high school. So we're going to start with trig definitions first. So to begin with, you could have different types of angles. So one situation would be the complementary angle and the supplementary angle. So a complementary angle is two angles that add up to give you 90 degrees. And it's usually denoted, this 90 degrees right here, is usually denoted by putting a rectangle in the corner to let you know that it is a 90-degree angle. These two angles, this one whatever this measure is, and this one whatever this measure is, these two angles have to add up to be 90 degrees. Whereas supplementary, you have two angles that add up to 180. You have an angle on this side and an angle on this side. And those two angles make a straight line. That straight line is 180 degrees. So for example, you might have a question like, can you find the complement and the supplement of 54 degrees? So hopefully this isn't too bad. Your complement has to be two angles that add up to 90. So if you're looking for the complement, what you could do is just do 90 minus 54. And it's pretty much that simple. I believe that's 36 degrees. And then your supplement, because they have to add up to 180, you just do 180 minus 54. And I believe that is 126. And that is the complement and the supplement of 54 degrees. This question says, find the measure of the unknown angle in this diagram. So we have two two angles. We know it's a right angle or a 90-degree angle. We haven't technically talked about what a right angle is, but it's a 90-degree angle. And so we have these two angles that are mentioned. You have a 4y and you have a 2y. And since it is a 90-degree angle in the corner, we know that the 4y and the 2y have to add up to the 90 degrees. And so I know that 6y equals 90, so y is 15. Now 15 is not the answer because it says find the measure of the angle. I guess it should say angles because there's two angles here. So y is not the measure of the angles. It's the value you plug into each formula. So the angle for 4y would be 4 times 15 or 60 degrees. And the angle for the 2y would be 2 times 15, which is 30 degrees. So depending on which angle they ask you about, those are your answers. One of them is 60 degrees and one of them is 30 degrees. Or they may ask you on the homework just to find what y is. And so if they do ask you just to find what y is 15. Now you can measure angles in what we call degrees with decimals, which is, literally a degree that has a decimal point in it, like 26.4 degrees. Or you can measure it in what we call degrees with minutes and seconds. So degrees with minutes and seconds takes your decimal portion of your measurement for your angle and turns it into not having decimals but having minutes and seconds. And so our rotation, one complete rotation around a circle is 360 degrees. So 360 degrees is one rotation. So what we do is we cut that down and say that we could do 1 over 360 of a rotation, or 1 degree. Apparently, that's the degree symbol off right there. So each degree can be divided into 60 minutes. So 1 degree is 60 minutes, and 1 minute is 1/60th of a degree. And then we could divide the minutes into seconds. So this works very much like time would. There's 60 seconds in a minute, 60 minutes in an hour. Your hours are like your degrees here. Therefore, if we were to go from degrees straight to seconds, then each degree is 3,600 seconds. And then we could divide that across if we wanted to. So if you wanted to add or subtract angles that have minutes and seconds in it, it's fairly easy to do. You just add your minutes together and then you add your degrees together. And if you end up with a number more than 60 minutes, then you carry that over to the next degree. On this first one, 62:18 added to 21:41. If you add 62 and 21, you get 83. Ooh, that did not come out well at all, did it? Let's try that again. 83. Sometimes my pen does weird stuff. And the 18 and the 41 come out to be 59 minutes. And that's your answer. But just for a sidebar, if you had one that was, say, 6 degrees and 24 minutes and 12 degrees and, say, 41 minutes, and you were to add those together, the 6 and 12 will make 18, but the 41 and the 24 make 65. So anything over 60, you have to subtract the 60 and add 1 to the degrees. And so when you add these, you actually get 19 degrees and 5 minutes. So anything that's over 60, you just move over to the next degree. Likewise, if you're subtracting, like on part B up here on the top, if you were to subtract these, you sometimes have to borrow, because you can't take 29 from 18 on the minutes because you'll end up with negative numbers. So what we do is we're going to borrow. We're going to make this 70 instead of 71 degrees and add 60 to the 18 to make 78. Not degrees, 78 minutes. Like that. That way we can subtract them. The 70 minus 47, you could technically borrow from the 70 and make it 6 and 10 if you wanted to. I'll let you all take care of that part on your own. But you'll get 23 degrees. And then the 78 minus 29 is 49 minutes. And so that's what you would do. And so you can borrow if you need to, if you're subtracting. Okay, let's convert some back and forth. So if you want to do degrees, minutes, and seconds and change it to degrees with decimals, it's not too hard to do. All we really need to do is just start dividing by 60 as we work our way across, or 3600 if we have seconds. So on this first one, the 112 degrees and 15 minutes, I would change this. The 112 in the front doesn't change, but I'm going to add to it 15 divided by 60. Divided by 60 because of the 60 for the minutes. 15 divided by 60 is 0.25, so I get 112.25 degrees. You'll also notice on a lot of calculators, you'll see a button that says DMS to DD on it. Most all scientific calculators can do this process for you if you would want it to do that. On the other one, 91 degrees, 35 minutes, and 34 seconds, I would take the 91, add it to 35 divided by 60, and the 54 has to be divided by 3600. Now, at that point, I've been doing these in my head so far, but I don't really want to do that one in my head. So, I'm actually going to pull out a calculator here and type it in. So we'll have 91 and 35 over 60 plus 54 over 3600. Yeah, and so you end up with something like 91.598 degrees. That's rounded off. Most of these things will be rounded off if you switch them back to decimals. That happens a lot. And so if you have to, just be careful on your rounding. The website tells you how many decimals to round it to, so just read carefully on how many decimals it wants. Okay, let's do the other way around. Convert from degrees degrees with decimals into minutes and seconds. And so what we do is we're going to just multiply by 60 multiple times, possibly. So the 3925, again, the 39 does not change. So it's 39. And then the 0.25, I take the 0.25 and I multiply it times 60. And that would be my minutes. So this becomes 39 degrees, and 0.25 of 60 is 15 minutes. That's the same thing that we just did on the last one. .76 doesn't come out quite as nice, so the 126 doesn't change, and I'll take the 0.76 and multiply it times 60. So if you take 0.76 and multiply it by 60, you get 45.6. So just this part right here is 45.6. That 45 becomes your minutes. So this is 126 degrees, 45 minutes, and the 0.6 that's left over will then get multiplied by another 60 to turn it into seconds. So the 0.6 times 60 gives you 36. So this becomes 126 degrees, 45 minutes and 36 seconds. And that is your answer going the other direction. Sometimes you do have to round this one off as well, so you might end up with like 36.4 seconds, and so you will have to round it off to the nearest second to make it nice looking. Okay, we talked about complement and supplement a little bit earlier, but we didn't do it with minutes and seconds, so I thought I'd show you one to do with minutes and seconds. So if I do the complement means I do 90 minus the angle, so minus 20 degrees, 10 minutes and 30 seconds. Again, you can borrow here. The 90 I would turn into 89, the 9 by the way, and you would get 60 minutes. But then I also have to borrow from the 60 to make 60 seconds as well. And then you can subtract them. 89 minus 20 is, 69? 69 degrees. 59 minus 10 makes 49 minutes and 30 seconds. Or if you do the supplement one, I would do the same process, 180 minus the 20 degrees, the 10 minutes, and the 30 seconds. And I have to do the exact same borrowing, and you'll notice that the minutes and seconds will actually come out to be the same. The 180 would turn to 179, so that I could put the 60 minutes here. The 60 would be turned into 59, so that I can borrow 60 seconds on the other one. 179 minus 20 is 159. 59 minus 10 is 49. And 60 minus 30 is 30. So notice the minutes and the seconds actually came out to be exactly the same. Only the number in front is different when you do a complement and supplement. Okay, another definition is coterminal angles. Coterminal angles are angles that differ by a multiple of 360. And so that would be an angle that stops in the same spot. So 32 degrees. If you want to find the least positive coterminal angle, then what you'd want to do is find the first one, the first positive angle, by either adding or subtracting 360. So like for 32 degrees, I could add 360 to it. And that would give me 382 degrees. I can't subtract 360 from it because I'd end up with a negative number. So the least positive coterminal angle here is 382. One thing about this though is when you're doing coterminal angles, the minutes and seconds never get affected. So on part B, the 26 degrees 30 minutes, I can't subtract 360 because I'll end up with a negative number, but I could add 360 to get 386, and like I said, the minutes and the seconds don't even change. So my least positive would be 386.30. On part C, it's already negative, so I definitely need to add 360 to make it something not negative. If I add 360, I'll get 320 degrees. That is the least positive coterminal angle. Now, as far as the 4854 in the corner on the other side here, you would have to take off several 360s because you're looking for the first positive coterminal angle, the first angle you would got before you went into the negatives. So we're going to have to subtract 360 multiple times. And I mean multiple times. So if I did 4854, let's see, you're looking at 13 times. I just did it on the calculator real quick. So you have to subtract 360 13 times. and you'll get 174 degrees. That would be the least positive coterminal angle, because if you subtract an additional 360, you'll be a negative number. So you want the least positive one all the way down as close as you can get to 0 without going into the negative. They may also ask you to find the greatest negative. And so if the greatest negative would be the first one that goes into the negatives. So basically you would subtract 360 on part A, part B, part C, and then part D you'd have to subtract 360 one additional time. Okay, here's a few other definitions here. The vertex is a point where two sides form an angle, and a standard angle is 0, 0. This straight line here in the middle was supposed to be a graph, and I don't know what happened to the rest of the graph, but I'll show you kind of a graph down here real quick. I'll draw one out here. Say you have an angle like this, and you have one side going this way, and you have one side going this way, and so there's an angle in between them. We usually label our angles with Greek letters, so most commonly the letter theta, but the point right here where they meet, that point right there is your vertex. Your initial side is the one that is in the blue. If you see color, it's the one on the x-axis if it's a standard angle. Your terminal side is the one that's usually out inside of a quadrant, in this case our red side right here. And standard position is where you have your vertex at the origin. So this graph that I just drew, that is a standard position angle. It's a positive angle if we move counterclockwise. It's negative if you move clockwise. And quadrantal angles are angles where the terminal side, so that red side, is actually on one of the axes, either the x-axis or the y-axis, and that occurs in multiples of 90. So we would start with this being 0 degrees. As you're rotating around, this vertical axis would be 90 degrees. So that's your first quadrantal angle. And then another one would happen at 180, 270, 360. You just keep adding 90 degrees. Okay, this says sketch the angle in standard position for here 57 degrees. Find the measure of the least positive coterminal angle and the greatest negative coterminal angle, and then find the quadrant that angle A lies in when it's 57 degrees. So I'm going to sketch it, and then we'll work on some of this other stuff here. So since it's in standard position, that means we're going to have an initial side on the x-axis going this direction. And the terminal side would be out in the quadrant. 57 degrees, kind of like what we just talked about a while ago, this is 0. This would be 90 for the first quadrantal angle. So 57 is not in the middle. Halfway between 0 and 90 would be 45. So you're a little bit more than halfway between the two axes. It says to sketch it in standard position, so that would look like this. So this is my angle. Well, actually, they call it angle A, so I'll put the A there. So this is angle A, which is 57 degrees. So there's my standard position of my angle. And it says to find the least positive coterminal angle and the greatest negative coterminal angle, and to find what quadrant it lies in. Well, the quadrant, this is in quadrant 1. So let's do the other parts. So the least positive coterminal angle. So if I have 57 degrees, I could add 360 to it to get the least positive. I can't subtract 360 because I'll go in the negatives. So if you add it, that's a 7, 6 and 5 make 11, carry the 1, you get 417. That is the least positive coterminal angle. If I want to find the greatest negative coterminal angle, I would take the 57 and subtract 360. That way, I actually will end up in the negatives, and that would be okay. So you get about negative 303 for the angle. So what does that really mean? Well, a positive coterminal angle, that least positive, the 417, says that instead of just rotating up to 57 degrees, I could have gone all the way around and then come up to that angle. That would be the least positive. Or the other one, the negative 303, says I started at 0 and went the other direction and ended up in the same spot. That's what least positive and greatest negative coterminal angles do. So you're ending the terminal side in the same spot, but you're rotating it different amounts. So you might rotate it more than one revolution, or you might rotate it the other direction. So now we're going to go into 1.2 and talk about triangles a little bit and angle relationships. So hopefully you know that the sum of all the measures of a triangle, no matter how big, no matter how small, all triangles have angles that sum up to 180 degrees. So if we want to find these angles, it's not very hard. If you want to solve for x in this case, I would have the x degrees, I would have the x plus 20, and the 210 minus 3x. All of this has to be 180 degrees. So it's very much like an algebra. You just want to gather your like terms together. So I would have that 180 would be, let's see, what do we have? We have an x, another x is 2x, 2x minus 3x would be a negative x. And then we have the 20 and the 210 make 230. Subtract the 230 from both sides. And so you'll get a negative 50 equals x, or negative x. So x equals 50. So that 50 is one of the answers. This 50 is this angle right here. This is 50 degrees. Then to find the other angles, you just stick the 50 in. So the top one, x plus 20, well, x is 50, so 50 plus 20 makes this angle be 70. And 3 times 50 is 180. 210 minus 180 lets this angle down here be 60. And so your angles are 50, 60, and 70. This example says to find the measure of the third angle given two angles. There's an assumption here that these are angles of a triangle. So it doesn't mention that here, but we're working with triangles here. So you're looking to basically just subtract 180 minus each one of these angles. So I'll do 180 minus 37 minus 52. And like I said, some of the stuff, a lot of the stuff you can type in the calculator pretty easily. And so if you did that, 180 minus 37 minus 52 gives you 91 degrees. On the other side, I want to do the same thing. I'm subtracting from 180 the 147 and 12 minutes. Now, I have found in the past that a lot of people don't like me to do the subtracting the minutes and seconds all at once. And that I won't do it here for that reason, but you could if you really wanted to. Because you do have to borrow, this becomes 179 and 60. So when you subtract them, 179 minus 147 gives you 32, and 60 minus 12 is 48. And then you could subtract off the 30, 19. No borrowing required there, so you get 2 degrees. And 48 minus 19, 4, 1, 3, 2, 29 minutes. And so that would be the measure of the missing angle for the triangle. Okay, we can classify triangles in three different ways by two different things. So you can classify them either by the side or by the angles, and the angles have three names and the sides have three names. And so we'll mix and match these things as well. So if you have angles, you have a acute angle, or a right angle, or an obtuse angle. So right angles, one right angle, the right angle means you have a 90-degree angle in there somewhere. Obtuse means that you have an angle that's greater than 90. Now you can't be, it has to be less than 180 obviously, because all your angles have to add up to 180, but you have an angle that's in there that's somewhere bigger than 90. And then on the acute means everything is less than 90. So if all your angles are less than 90, you are acute. If you have one right angle, you have a 90-degree angle, and it's obtuse if you have one angle that's bigger than 90. And then you could relate it to the sides. You could have all your sides be equal. That's what these little tick marks on the side of the triangle are for. So if they're all the same, they have the same length, and so that's an equilateral triangle. Isosceles means that you have two of the sides the same, and scalene means you have all three of the sides the same. Oh, sorry, all three of the sides different. And so you might classify a triangle as a acute equilateral triangle, or you might say you have a right scalene triangle, or you have a obtuse isosceles triangle. So you can mix and match the names, and we'll do that in some of the examples. So to classify this as either acute, right, or obtuse, and then either as equilateral, isosceles, or scalene. And it doesn't matter which one you do first. This one has the angles and then the sides. If you look at all the angles are the same. They're all 60. But the important thing is that they're all less than 90. And so since all of these angles are less than 90, this is an acute triangle because all the angles are less than 90. All the sides have the same length. They're all 10.5. And so since they're all the same, this is an equilateral triangle. Now, by definition, every equilateral triangle is acute. So sometimes you'll notice if you're looking at different papers or whatever, they may say you have an equilateral triangle. That has to be an acute triangle. But the other way around is not true. Not every acute triangle is equilateral. So sometimes they'll leave the acute off if it is equilateral. So here's two more to classify. The first one, part B, you have a 45, 45, 90 degree triangle. So because of the 90-degree angle in the corner, I know this is a right triangle. And you might notice that two of the sides are the same. One of them is 14.8, the other one is 14.8. The hypotenuse is different. So you have two sides that are the same and one that's different. That is an isosceles triangle. Part C, every angle again is less than 90. So this is acute. And every side is different. One of them is 15, one's 21, one's 22. So if everything's different, it is a scalene triangle. This is an acute scalene triangle. So for a triangle ABC to be similar, and similar is kind of the word you're looking for here, similar, to triangle DEF, they're not the same triangle, but they are the same sort of triangle. The following conditions have to be true. All the angles have to be the same measure. If they're in the same spot, they have to be in the same measure. And the sides have to be proportional. So if you were to divide two of the sides on one triangle and the same two sides on the other triangle, they have to be equal. And so if they are, we can say that those two triangles are similar. Find all the unknown angle measures in each pair of similar triangles. So sometimes they're rotated differently. So this case is here. I don't know what happened to the P here, so we're going to make that more of a box. There we go. Triangle ABC, and we have triangle QRP. We know that they're similar because it says they are similar, and it says to find all the angle measures. So you may want to take this triangle on the right hand side and rotate it to be the same as it is the first one. If I did, I could flip it over on this axis, and you might have to bear with me, my drawings are awful, but if you were to flip it over, then you would have the triangle sitting this direction. But the important thing is to notice that the angle up here at the top would have to match with the angle up here at the top. The angle over here on the right would have to match with the angle over here on the right. You already know that angle C and angle P are both 90 degrees. So they're really just asking you what is Q and what is R and what is B. And so since A is 42 and Q is in the same spot, it must also be 42. Because all the triangles have to add up to 180, if I took 180 and subtract 42 and subtract the 90 for the 90 degree angle, I'll find my missing angle. So 180 minus 42 minus 90 gives you 48. This is 48 degrees. That 48 would be not only B, but also R, because they are similar. The angles are usually easier to do than the sides. So speaking of the sides, find the unknown side lengths in each pair of similar triangles. Again, you might want to flip them to be the same direction if you want to. It doesn't really matter. If I flip this one here to be the same direction, I would have a triangle sitting this direction with the A, the B, and the 25. So let's start with side A. For instance, I could do side A divided by 25. I could say A divided by 25. That's dividing the vertical side by the diagonal side. And on the other triangle, that would be 8 over 10. So if you were to either cross multiply would work. If you cross multiply, you get 10A equals 25 times 8 is 200. So A must have been 20. Or to find B, I might divide B by 25 and set that equal to the 6 divided by the diagonal 10. Do the same thing, cross multiply, and you'll get 10B equals 25 times 6 is 150. So B is 15. And you might say, does it matter which sides do you divide? And it does not. You could do A divided by 25. You could do 25 divided by A. You could do 8 over 10 or 10 over 8. Doesn't matter. You can mix and match them anyway as long as you match the sides, the ratio is the same from both triangles. Okay, let's do that with a word problem though. A tree casts a shadow that is 60 meters long, and then you have a stick in the ground casting a 3-meter long shadow. Can we find the height of the tree? And you can. So this is where your artistic skills can come into play if you want them to. So we have a tree, especially if you have like colors you're playing with. See, there's my tree. Might have a branch over here on the side. You know, put a little grass on the ground. Grass, yep, there it is. We do make one major assumption though, that our trees and our sticks and everything are exactly the same, like up and down part. And so we have a tree that casts a shadow on the ground. The shadow is 60 meters long. So the 60 would be the flat side. The shadow would be on the ground. So you'd have to be the flat part. The height of the tree is what we're looking for. So I'm going to call that H. And at the same time, there's a stick in the ground. So depending on how well you want to draw a stick. So there's the stick. He's buried in the ground, sitting on the ground. And so it has a shadow that is 3 meters long, but it's 1 meter tall. And so we're going to do the same thing with the ratios. I can divide the h over the 60 and the 1 divided by the 3. The h over the 60, the 1 divided by the 3. Or you might say, well, could you divide h divided by 1 and 60 divided by 3? Yeah, you could. It doesn't really matter. Like I said, you can really mix and match them any way you want to. So you'll get 3h equals 60. So h was 20 meters. That tree is 20 meters tall. A little few birds flying in the background. Okay, same idea. We have a house that's 20 feet tall, casting a 40-foot long shadow. And then you have a nearby building that's 500 feet shadow of a nearby building that's 500 feet long. Find the height of the building. So we have a house. So house, 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 house. So maybe you have a door on this side here. You got some windows. Looking out. Maybe there's a chimney on the back. It's cold, so got a little smoke coming up back. Got a few windows on this side too. People like to look outside. Maybe you have one of those little, hanging things on the house where you have a little attic space. I don't know. Like I said, this is your time to be artistic. And I'm not artistic very well, so. And, everybody needs birds flying around. But anyway, you have a house that is 20 feet tall, and it has a 40-foot shadow. At the same time, you have an office building. So here's my office building. Now, if any of you are from the Tupelo area, I grew up just north of Tupelo in Guntown. And the biggest building I saw growing up was the Bancorp South building, big glass building in Tupelo, downtown. And so whenever I have a building I have to draw, I always think of that particular building, just because that was the building I remember seeing growing up. Maybe it has a radio tower on top. And so you have this massively tall building. And I know it's massively tall because the shadow is 500 feet long, and we don't know the height. So we do the same thing. We're going to compare the sides. I'm going to say the h divided by the 20 equals the 500 divided by the 40. And again, cross multiply. So you get 40h equals 500 times 2 would be 1,000, so I get 10,000 there. And 10,000 divided by 40 gives you 250. So that building is 250 feet tall. Some of you might also notice that looking at the house triangle, the shadow is just twice the height of the building. So you could take half of 40 to get 20. If you take half of 500, you get 250. It's the same thing. That is using the ratios that way as well. So you could do that if you notice that. So this one's a little bit trickier on the fact that the two triangles are actually lying on top of each other. And so you have one triangle that's sitting right here, the 60 and the 120. So there's one triangle there. And then there's the bigger triangle, which is the entire thing, including the part that goes with the blue part. So you have two different triangles sitting here. And they want you to find the missing side x. And so I have to take this side and compare those. So I could do 60 divided by 120 and set that equal to my other sides, which is the vertical side, which would be the x, divided by the horizontal side. The horizontal side, though, is not the 150, but it's the 150 added to the 120, the whole side across the bottom. So 60 divided by 120, if you want to simplify that, you could. That's just a half. And so the 150, the 120 is 270. So if you cross multiply, you get 2x equals 270. So x is 135. Just half of 270. And that's your answer. So hopefully this is going pretty well. If you have any questions, just let me know. This is the end of the first two sections. So this is the end of the first video. This is where your first homework will stop. And so anything you want to work on in the first homework should be on this type of material. And like I said, if you have any questions about any of that, just let me know. I'll be glad to answer whatever.